everybody, and welcome to the first Sunday of the new year, and the first Sunday of the month, and our little get-together from London. We are going to be reviewing the year, and we're going to be looking forward to this year. Reviewing last year, obviously, and looking forward to this year. And Rob, hello, sir. Would you like to say hello to everybody?
I'd love to.
Fantastic.
Hello Facebook, how are we doing? Thank you for coming to my lounge. We're really excited to have this event going on. We're going to talk today, as Phil said, about a review of the previous year and some things that are going on in the Electric Universe community in the coming year, and a few plans we have for our events going forward. We're very excited that, very grateful that Wal Thornhill will be joining us in a bit.
The first Sunday of the month,
and we'll get started, I think, with something from Phil. You're going to show us a video.
Yeah, absolutely. Yeah, well, we're going to start. We're going to show the paradigm shift that is happening now and reaching out far beyond our community, but into the people's consciousness and science generally. And yeah, so this is a first little video clip. Let's take that, and we'll see where we're starting and how much this is now getting into the much bigger audience.
Earth-shaking revolution in human thought is coming.
The impact of the electric universe paradigm is unprecedented. It's probably the biggest paradigm shift in history.
I cannot identify a paradigm-shifting set of ideas more profound, more fundamental, more sweeping in their implications than the electric universe paradigm.
The electric universe acknowledges the fact that all matter is electrical in nature, and that we can understand far more about the universe, cosmology, and ourselves by using this understanding and applying it to a simplification of all of the present physics, which involves multiple forces and multiple particles, and a complete zoo of particles, and a lot of confusion, especially with some of the very expensive experiments that have been carried out recently, which have produced just more surprises rather than confirmation of previous ideas.
The electric force is not limited to a particular scale. We see profound examples of electrical activity up at the macrocosmic level. That means even a larger scale than the galactic space that is being filled with electrical activity as we observe it now. We didn't realize this, but it was predicted by the pioneers of the electric universe that we would find intensely energetic electrical activity at the hearts of galaxies. But the galaxies are not actually the largest scale of electrical activity, and we know that by seeing how galaxies in large clusters are aligned in particular directions. That could not happen by random evolution of the cosmic system from gravity. And all we have to work with as alternatives, theoretically, are electricity, or the electric force, and Newtonian gravity. So the electric force wins. That's our bottom line.
Each era seems to work with its own mythology that sets the ground rules for what you believe and what you don't believe, and science is just another mythology. It's funny because science, of course, is supposed to have separated from religion. It never did. It even took the creation myth with it and added maths to it to suit whatever they wanted to dream up. And so we've ended up with a scientism. You know, it's really nothing to do with real science. The biggest problem is always to let go of the things that everyone else believes, and you think if I say anything against it, I'm dead. Get over that and just keep going where the evidence leads you. I suddenly realised that to get any further, I had to discard Einstein's way of looking at things. I had to dump Einstein and go back to the classical way of doing science. It was a necessary step. I had to take that step to take the ones that were just to come, just down a few years later. No one can question him because everything that's ever been done confirms his work. Well, that's so simply because he removed the standards of measurement of time and distance. So once you've done that, and you can choose any arbitrary observer in the universe to match to give you the results you want, sure, you know. But the fact is that doesn't actually prove anything because his work is fundamentally, physically meaningless.
And Einstein's general theory of relativity is riddled with contradictions, impossible physics, so-called physics. It's a bit of an oxymoron to say physics, but impossible physics and invalid mathematics. So there are two things that a physical theory must satisfy. It must be logically consistent and it must be in accord with reality or experiment. Well, if it fails on either one, then it doesn't hold. And in the case of Einstein, certainly on the question of logic and self-consistency itself, it's false.
Belief in the speed of light being a limit. Einstein said the speed of light was with respect to some arbitrary observer. That can't be so, because then you've got no way of measuring the energy of somebody who's moving with respect to somebody else. It also means that the clock paradox goes away because the clock's rate of ticking depends on its energy, and that depends on its motion with respect to the rest of the universe. So Einstein's inertial frames of reference are not equivalent. They cannot be equivalent. So that destroys special relativity at a stroke.
Destroys special relativity at a stroke. Yeah, there's many reasons why Einstein was wrong in his assumptions and chucking away the electromagnetic ether. But it was interesting the fact that these videos are now being produced by other people. This was not a Thunderbolts project video. This is produced by someone else, and someone called
Caesar's Messiah.
Which is very strange, and which when I first showed this to Rob and sort of said we're going to use this tonight, he said, that's Caesar Messiah. I said, who? I didn't know who he was talking about. But this goes to show how even the electric universe paradigm is now going over to the spiritual realm, because a lot of people are seeing whatever you think of as God as a big electrical circuit, of which how we think as well by electrical circuits, the way our bodies work. So a lot more spiritual people are letting go of the Big Bang the hypothesis. There's no evidence for it. I can't even call it a theory really. And they're now looking at the electric universe as an explanation for their beliefs as well. And yeah, so it's a bit strange.
Oh, this might be Wal.
Absolutely.
It's Mr. Thornhill.
Oh, come on.
So,
help.
we're having a few technicals. Caesar's Messiah is...
There we go, and he's on. Whoa! How are you?
Welcome.
Well, welcome to it. We've just started and you managed to get up really, really early, which is fantastic.
Thank you so much.
Well, so what time is it your place?
It's 20 to 5 in the morning.
Oh, blimey. Oh, thank you so much, sir. Okay, well, we'll carry on and you can interrupt and we'll ask you and we'll carry on and chat as we go along. Anyway, we're now obviously reviewing the 2018 and the year started with the announcement that the Electric Universe community was going to hold their first conference outside the US and hold it in good old UK. It was brought together by Adrian Gilbert, who suggested doing it. There has been people in the past, but obviously you need funds and the gumption to get on and do it. And Adrian stepped up to the plate, put his money where his mouth is, and got it going. And then with Lucy Wyatt, they got it going, and what a fantastic time it was. So now we're just going to play a little just behind me on that, I'm going to play a little slideshow that I put together from some of the pictures which I took down at our event. So let me just get that going. That one's out the way, and when it comes up, deciding to be slow for me. Thank you very much. Yeah, so when we was down in Bath and Somerset, and of course this is where me and Rob we got together. Honestly, there we go. Finally got there. We'll be once it gets going. Once it loads. Yeah, so this is where me and Rob actually met. And it's typical. It doesn't want to actually show it now. Hold on, where are we going? Hold on, what happened there? Yeah, so do you want to, while I'm sorting out, do you want to just say...
Okay, so we just showed a video
it's
paradigm
okay.
shift, and here we go. Hang on.
Here we go. Finally got through to us.
So, first of all, as Phil said, this is where he and I met. I've never been to what I'd call a quote-unquote alternative physics, alternative science conference before, and I was amazed and delighted by the interaction and the openness of everyone. I just wanted, first of all, I wanted to ask, obviously for us, this was a highlight of 2018. I wondered what for you about that conference you took away from it, what memories you have?
I think the most important thing was that we had such a good turnout, and also the calibre of the speakers and everything was just great. And the follow-on, the 3 days, I thought was an excellent idea because it gave those who wanted to delve a little deeper and meet the key people in the Electric Universe movement and talk to them.
I have to say, for me, it was very exciting to meet yourself, to meet Don Scott, to meet Michael Claridge. It was very much kind of like the Beatles getting back together and forming for me in Bath. I was very excited. I think you could probably tell at the time.
I think, the other big aspect of it was that I'd always wanted to be able to spread our meetings out of the US to other places. You know, I'd like to have one back in Australia, for instance, but at this stage of proceedings, I think it's probably a little early.
Right. Yeah, I mean, we've been gathering maybe a dozen or so people together on a monthly basis, sharing ideas, sharing projects. We're going to speak a little bit about that later, but I wondered if you'd like, there are 2 or 3 things that stand out to me about what happened this year, and I'd really be interested in your response to them. The first, I guess, would be the article in the American Geophysical Union paper. I don't know if you saw it. They do a magazine called Earth and Space Science. Did you see?
Yeah, that's right. I was a member for many years, and I keep up with their stuff.
It was last April, wasn't it?
It was April, yeah.
Yeah, and they basically said you have to look at electric currents in space. So it very much all sort of like gels with how last year big things changed. Obviously.
I'll say this arrived this week.
Oh, okay.
And this is their publication.
Oh, wow.
That's their publication.
Yeah.
What?
Yes, $180 something
Oh, wow.
US.
Wow. And have you had a good look at it yet, or is it something on your
I've had a scan. I've been busy working on Ultima Thule.
Right.
Oh, right.
Another great event that happened this year. I've been reading with interest the gravitational. I'm going to use the word explanations for how that happened. Would you like to elaborate?
It's just cock and bull.
Well, yeah. I mean, yeah, these two masses dancing in space and then kissing like that. I mean, I have to say.
And when you think of the vastness of the volume of that space out there, the chances of 2 things hitting are about zillions to 1 against.
Yeah, absolutely. It's just the fact there's so many peanuts out there. I mean, it's
That's right.
It's ridiculous. Anyway, going back to where we were, going back to my little script. When we met up, we decided to sort of like start this. Is Rob, myself, and Piers. We decided to start this, and we decided to get the media presence going, which is what we see here tonight, and we are now well and truly set up. But we've actually been doing some other stuff, and we've been looking at the medical side as well, which I know we talked back in July about trying to actually expand that. And now we've got our own resident doctor on board, who's been very shy and sitting behind the camera over there.
Can't see him.
But hopefully he's going to come and say hello, Chee. Come, Dr. Chee Wong. Say hello to Wal.
Nice to see you.
Hi, welcome.
Yes, and Chee is. But we're going to talk about that later when we get into what's going on next year. But we've got a very exciting little project we've been talking about, and we're going to be getting going, and that is very much Electric Universe inspired. So, but we'll talk about that a bit later. So we wanted our Sunday get-togethers to have the front room type of feel, and that's exactly what we've achieved.
This is my front room.
Because we're actually in Rob's front room. Because again, it was to test the technology. We started out at Mac, which we really appreciate for Christian and Mac to actually let us have that space. So obviously we had to pay for it, but it was good. We had all their facilities, and Christian's an old friend of mine. So it's good. But now we've got it all set up, and we're now taking it out on the road, taking it out on the road, and we're showing that we can literally do this from anywhere. We can have a Skype guest come in, and we can then broadcast that out to Facebook and all the different streams. So the technology is working very, very well. So what else? Let's show you this little slideshow we got. So we'll just come out of this. Come down in size on that. Come down in size on that. That way there. And this is our slideshow, which I put together from last July. Yeah, so this was really quite monumental for us in the UK, actually getting this going and getting our side of the pond really activated and up and running, and it sparks a big question also in mainstream science about the timing of things, and something which occupied your brain, which was what Jeremy was saying, Jeremy Dunning-Davis, who joined us last month, if you remember, about how science, unfortunately, people have to die for science to move on. There's no easy way of saying this, but things are changing since the death of Stephen Hawking, and we are now, I think, really on the cusp of the big change. Like we said, you know, they're actually talking about electric currents in space openly now. We're seeing Jeremy Dunning-Davis being asked to referee for publications where he was banned before, because in proving that Stephen Hawking was mistaken, shall we say, mathematically. And yeah, this is now really getting to a good place in the world of.
Well, David Drew wrote that article, A Brief History of Unicorns, about the passing of Stephen Hawking, and again, Jeremy Dunning-Davis speaking about it at the conference really opened up for me the power of personality, almost the cult of personality. Stephen Hawking was almost the embodiment of a theoretical physicist, in that he was only a brain. He couldn't do anything practical, and there you have his passing, seemingly opening up those doors for physicists who previously disagreed with him. The example Phil and I are best acquainted with is Jeremy Dunning-Davis, because we met him at the conference and then went to see him speak in London, and had him come and speak for us. And it's more of a social phenomenon than it is a scientific one. And I was really impressed by his patience and his kind of equipoise, because he'd spent 30 years saying, I believe this. There he is, picture Jeremy. 30 years. Good timing. 30 years holding the same position, very mild, in a very mild-mannered way, and now he's been not proven right, but given a lot more validation. The same publications that were saying you can't publish here are now asking him to referee. And I wondered if you were aware of other people in the community who had experienced similar changes in fortune, shall I say?
Yeah. Do you see science being pivotal now? Last year being pivotal in a change? Well.
Sorry.
Yeah, that's all right.
Yeah, well, there has been a slight change. I mean, that book, for instance, that I just waved at you, it looks like a first attempt to say we knew it all along. And this is one of the reasons why I want to go through it and see exactly what it is they think they know. I've never felt threatened by someone coming along and saying we knew it all, because there's no way any particular person from any particular specialty can say they know it all, because the electric universe is the first time we've had a big picture version of cosmology. In other words, that any subject at all can be talked about sensibly in terms of the electric universe, and that's a first. So any expert in any field can't really produce the electric universe on his own. He has to be able to arrange across all the different subjects. And it was Velikovsky who taught me how to do that.
Yeah.
So I give him credit for the original inspiration to see the imaginative leaps that he made. And being, of course, a classical scholar himself, this is the way we've got to go. We've got to go back to classical physics. I mean, we stopped doing physics when Einstein and Bohr and the Solvay conference happened at the beginning of the 20th century, because Einstein removed all of the standards of measurement. Length and time suddenly became rubbery, and Niels Bohr provided a kind of statistical science which has no cause and effect. So you've removed the basics of physics from science at that point. And the result, of course, is complete madness. You know, it's just complete shambles now.
It's not something that's it's not something that's well appreciated that really all that's happened since Solvay are technical improvements, and there's been no real breakthrough in physics. Why do you think that is? Is it conservatism? Is it information management? What's your take on that? Because I find it fascinating.
Well, I think that the fundamental problem is that cosmology has always been related to religion, despite the fact that scientists say they're separated. You know, they have the answers, and religion is a matter of faith.
Yeah.
And of course, this has been tradition right from the very earliest days. It was always the astronomer priest. And this simple evidence that what we have now is a different religion is the fact that you have books like that of Paul Davies, you know, about the mind of God.
Yeah.
And mathematicians thinking that they can have a theory of everything that you can print on a T-shirt. The arrogance of that is phenomenal, because to say you have a theory of everything means you know everything.
Yeah.
And
we're a very long way from knowing everything. That's obvious, isn't it?
It's just sheer nonsense. We have to be able to acknowledge the areas, the things that we don't understand, and make sure that it's made clear what it is we don't understand. Well, there's no clarity at all now, because they've invented so many things that don't exist. And that means that if you're going to have a theory of everything, it has to include black holes, dark matter, dark energy, all this absolute nonsense. And the other thing that I've said about human nature is that we're not well designed, if you like, to be able to do science, because the psychology of how we learn and how we do science is ignored by the very people who do it.
Yeah, absolutely, and this is something we're going to touch on later, because we're trying to start the education on this side of the pond, from basic education right up to the academic level, is where we're getting Piers Corbyn involved, who will be popping along later. We've had word that he's on his way, but usual, should we say, late.
Can I just say, because you seem to be, and this is for everyone, but mostly for me. I mean, I've got here what I think you were referring to then, The Master and His Emissary by Ian McGilchrist. Thank you so much for recommending that. I've also got The Big Bang Never Happened by Eric Lerner, and Bankrupting Physics by Unzicker. You've provided me with half my year's reading list, so thank you. But I was wondering if there's anything I'd missed or anything you'd recommend for this year going forward, preferably something that doesn't cost $180.
Yes, that's right. The reason I bought it is I thought, well, no one else is going to buy it.
Doubled their print run.
Well, someone's. We give them lots of advertising, that's for sure.
So
the other thing is talking about books to read. All of the stuff behind me. I mean, there's several levels of books and stuff going way back to when I was at university. And in front of me is a similar setup, you know, so that there's a mirror image on this side of the room facing me, and then there's a stack of books about a foot high, which I bought recently, which I've just been thumbing through.
You're going to have to get your own library. You need another room.
So, just again,
that's right.
Anything you'd recommend that you read last year, or anything you're looking forward to reading this year?
Well, maybe I should grab some of these books behind me and give you an idea.
I'd certainly be up for that. Thank you very much.
Can you just find that up a little bit?
Where are you?
Wal Thornhill's reading list.
I know.
Amazing. We are privileged.
2 or 3 will be fine.
Well, maybe this one you don't want to look at. It's Richard Feynman's 6 Not So Easy Pieces.
That's very interesting, because I'm just about to actually play a clip by Richard Feynman, and one of my favourite clips from 1963. Anyway, carry on.
Yeah, this is Rupert Sheldrake's, of course.
Yeah, read that.
Science and Spiritual Practices.
Okay.
That's very good.
Of course, this one, Against the Tide.
Against the Tide.
Ah, okay.
Yeah, that's by Martin Lopez Corredora. I've also got it on my iPhone, so when I've got nothing to do, waiting in a waiting room somewhere, I'll read that.
Great.
It's just full of good stuff. There's other books here too, which I wouldn't recommend just yet, but I get a lot of books just to see what other people are thinking to make sure that I haven't missed something.
Yeah.
And also to check that my basic ideas can explain what they're trying to explain without all the usual nonsense.
Yeah.
Because one of the problems I find for most dissident scientists, and there are thousands of them out there, is that they use the same language that the experts use. And the experts' language is basically meaningless. Most of the words they use, they don't understand. I mean, they haven't defined mass, they haven't defined energy, they don't know what the speed of light is, they don't know what light is. I mean, these are just fundamentals.
Yeah.
And yet they use them as if by using the same terms and the same language as the physicists, that they're actually talking sense, and they're not.
Mm-hmm.
But for anyone who's interested in Einstein's work, the book Old Physics for New by Thomas E. Phipps is a must-read.
Old Physics for New.
Yeah, because he deals with the physics, and there are some equations through it, but he writes in a very readable style and has some really quotable quotes against modern science.
So I'm on Amazon now. I'll be buying that in the next 5 minutes. Thank you very much. So you really have given me hours of reading, which has been incredibly rewarding.
Yeah.
I have to say again, I've never been to what I'd call an alternative science conference, and I don't think I'll ever go to any other ones apart from this, because the work you've done for me, I don't know if you remember, but about 2.5 years ago, I got in contact with you because Rupert Sheldrake had recommended it, and you very kindly sent me your book without me paying for it yet, so that was kind of you. I did pay you back, but like once I was able to absorb the information, I can't tell you how grateful I am, because having read a lot of popular science, dark holes, black holes, dark energy, dark matter, and just being left in a mystified state, the clarity you and the electric universe bring to the way the mechanics of the universe is beautiful and wonderful. I can't tell you how happy I am again to have you in my lounge, sir. So thank you very much. You're always welcome.
Right, have you finished waffling?
Yeah.
That's good. Okay.
Yeah. For the minute, I'll have a coffee.
Okay, now we're going to, because we talked about Richard Feynman, we are now going to play a short clip. A lot of you will know this, but for those who are new to this is what he said about how standard model physics, in inverted commas, is actually brought about, and it's not done by the way that the people in the Electric Universe and Associated do it, or the people of the old. This is very much, well, I'll let Richard explain it himself.
In general,
Hold on, this
now I'm
one.
going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we don't laugh, that's really true. Then we compute the consequences of the guess to see what, if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature. Or we say compared to experiment or experience, compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. In that simple statement is the key to science. It doesn't make a difference how beautiful your guess is, it doesn't make a difference how smart you are, who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it.
Now, I think that is absolutely lovely. That actually had some integrity to it, and yeah, why haven't they given up? Well, why haven't they given? Why do they keep persisting with this?
I think it's because they've never been taught how to compare different ideas. You know, the way you're taught in school, you have this whole series of facts and the equations which are supposed to describe the results of the experiment. And if they don't match, they don't have another guess. What they do is they go back to the same model and they twiddle with it. And they put extra variables in. You know, these extra dimensions they talk about are merely extra variables, so that by the time you've added 1, 2, 3, 4 extra variables like dark energy, dark matter and black holes and whatnot, you can practically produce a virtual universe that will match anything that you can see. But it doesn't mean it means anything.
No.
And that really is the problem. We're not teaching people in school to think critically. For instance, if I was running a university, I'd make it absolutely a rule that all of the great so-called breakthroughs in science and the great scientists of the past, their work should be examined in the context of the times, and those major scientists at the time who disagreed, their arguments should be compared with those of the person who so-called won, because often the winning was a democratic process with show of hands and who was the biggest name in show business at the time. In fact, when I look at the history of ideas, Eddington was probably the greatest fly in the ointment when it comes to advancement, because he championed Einstein, but he did that for reasons of his own.
Yeah.
It had very little to do with science. He went out to prove Einstein was right. It wasn't a case of test, it was a case of prove it, come hell or high water, because he had to re-establish himself. He was a candidate for the White Feather after the First World War. And so this was a way of re-establishing himself by saying he was the only other person who understood Einstein, which was rubbish because no one understood Einstein.
Yeah, they only pretended they did. The thing is with maths, it's just a language, isn't it? Really, you know, you can use it to describe reality, or you can use it to describe pure fantasy.
Well, that's true, Phil. The problem with the way mathematics is treated is the only path to the truth is that it is merely a descriptive language, and the problem with the maths that we feed to kids in school is that most of the symbols on the board are not actually defined physically. And unless they're defined physically, you have no idea what it is you're talking about.
They're just abstract concepts, yeah?
That's right. It has to have a physical explanation, a definition. And without a definition of mass and energy, Einstein's equation is meaningless.
Yeah.
In fact, the E equals mc squared that they attribute to Einstein, you've seen the work on intersect recently, people who have been looking at these issues and pointing out that it was actually discovered by the classical physicists.
Yeah, well, it went on before that. There was a slightly longer equations, and there was people like Poincare, was it, and some others who clearly wrote down these slightly longer equations. So it shows they were heading in that sort of direction anyway. But Einstein obviously
they actually derived E equals mc squared from classical principles. And in fact, when you analyse it, all of the technology in that's being used today for these amazing experiments and space shots and things that they do, based on the work that came before Einstein and Bohr. In fact, transistors were invented before Niels Bohr came along, and yet they're supposed to be representative of the quantum behaviour of solid-state material.
Well, that's a typical case of sort of looking and then trying to shoot that horn into existing guesswork and trying to prove.
Well, you rewrite history to suit your beliefs.
Yeah. All right. Well, now we're going to go on to a slide. I want to show a bit about the Sapphire project, because obviously that's massive in our community, and it is obviously the biggest piece of experimental science which is being undertaken at the moment by people connected with the Electric Universe. And yeah, this was Dr. Michael Clavidge. We're going to see that in a sec at the conference. But the thing of stars, it's like Robitaille. Dr. Robitaille obviously has this liquid metallic. And we want to discuss with you the differences between like the plasma sun and electric sun and the different models. But first of all, let's just see what Dr. Robitaille says.
Hello everyone, Happy New Year and welcome to Sky Scholar. In previous presentations, I emphasized that the body of the sun is comprised of metallic hydrogen. It is made of condensed matter, not gaseous plasma. The sun has a real surface, which is not simply an optical illusion, as currently advocated by astrophysics. The realization that the sun is condensed matter brings with it a new understanding of the stars as well. Like the sun, they are not gaseous plasma in nature, but rather, their bodies are also composed of condensed matter. Hence, it can be argued that a liquid metallic hydrogen model of the sun also changes our fundamental understanding of the stars. Many might say that if a condensed matter model of the sun is adopted, then the stars cannot be properly explained, especially the white dwarfs and the red giants. In fact, you will come to recognize that the lattice structure that is so vital in properly characterizing the sun elegantly translates to a more profound understanding of other star types. The fact that the sun is comprised of condensed matter leads us to recognize that stellar material is essentially incompressible. This was something which James Jeans had argued long ago, as you can learn here. Recall from this video that the sun has an average density of approximately 1.4 grams per centimeter cubed. In addition, the sun has a core which experiences solid body rotation. Consequently, the center of the sun cannot be hollow, as we previously saw. As a result, if one insists that the photosphere is comprised of condensed matter in order to properly account for the solar spectrum, then the sun must have a relatively uniform density throughout. The center of the sun simply cannot achieve densities of 150 grams per centimeter cubed. There is not enough solar material to achieve that value and to maintain a liquid metallic hydrogen-based photosphere. It is because of considerations such as these that stellar material must be viewed as essentially incompressible. As a consequence, the sun and the stars cannot collapse into black holes as they age. I have argued that black holes violate the laws of thermodynamics. They are nothing but mathematical manipulations, and astrophysics will eventually come to the same realization. The stars are condensed matter, and that is the lesson for today. They will not collapse into super compressed objects and not evolve based on changes in nuclear fuel. When they differ from one another, it is a question of lattice structure, not of the nuclear fuel being burned. As I have stated before, the sun can make all the elements, and so can the stars. To argue otherwise is to impose upon the stars restrictions which are in large part based on our outdated ideas relative to the nature of the sun itself. Hopefully, we will cover all of this and more in the coming year. But for now, spend a little time reviewing the key presentations about the liquid metallic hydrogen model of the sun. That way, you'll be ready to start thinking about the stars. If you enjoyed the video today, promote the channel. Mention the videos to your local...
Thank you, Doctor. So well, do you go along with a metallic hydrogen?
No.
What do you say?
We have this is one of the problems I've faced many times over the decades with people who felt they have the answer, is that they usually come at it from a very narrow perspective. And Pierre Marie has obviously done good work in thermodynamics and with his MRI invention and also explanations. So when it comes to space, he doesn't understand plasma. And to say that you need a condensed body to produce the black body spectrum is incorrect. Plasma does it in a process called magnetobremstralon acceleration of ions. Now, and in fact, you can look at the literature on plasma, and it's pointed out that the spectrum of the sun and other bodies like that is what you might call grey body radiation. It matches the black body spectrum, but it's slightly off centre, if you like. The reason that it gives a black body spectrum is that you've got ions accelerating, in other words, going around in spirals in a magnetic field. And because the ions are of different masses, good evening, Piers.
Good evening. Good evening.
Oh, you noticed it's finally arrived.
Oh, yes.
Yeah,
72
we're
plus
discussing
is a bit of
PMA
a
role types, liquid, metallic, sun. There are a number of
metallic
problems
core.
with it.
Yeah. Okay.
So what do you go with, Well? What is the sun, in your opinion?
Well, the sun's exactly what we've been describing and what Ralph Jerkins theorised. But there is an added factor, and that is that Pierre Marie's model doesn't explain where the energy of the sun is coming from, and it doesn't explain any of the detailed features of the sun and above the sun. You can't just dismiss all that work, and one of the difficulties I've always had with Pierre Marie is that he is very much in your face with his ideas.
Who isn't these days?
Yeah, and doesn't listen to us. So of course, we've invited people to speak at our conferences, and we say we don't agree with everything they say. It's just a case of we want to give people a chance to point out what's wrong with our work.
No, absolutely, because none of us can be right all the time. However clever you are, like yourself, we can't, we can't all be right, and this is what's good about our community. We can actually civilise and talk about it and chat to each other about it and discuss ideas, which is really good.
Well, the thing is that when he did that, I thought, I've got to know what the real answer is, see whether he's got any reason to say these kinds of things. But there are a number of other issues with it. One is that by dismissing the electrical input to the energy of the sun, he leaves the question totally open. Why is the sun shining? Why does it look like it does anyway? And what's producing the energy in this solid?
So does he go with the nuclear model?
Well,
or is it unclear?
It's sort of implied there, but how do you do that? To produce that energy in a solid body, no one's ever said how you can do that. The other thing is he doesn't understand gravity. Nobody does it, apart from the only model that explains gravity is the one that I put forward, and it does that in terms of the structure of matter.
Yeah.
And I've been very pleased to find out that this kind of answer to the structure of matter was actually hit upon by scientists back in the 1850s. They were within a hair's breadth of getting to the electric universe back then.
Wow.
So this is always good to be able to look back and find some of the big names in science in the past who got close to actually we're on the path to the
going down the same road, basically. It's coming to the same conclusions.
Yeah. The other thing is that with no understanding of gravity, people just blithely assume that by measuring the gravitational influence of a body, they can tell you what it's made from. They can't. Because the gravity is not purely dependent upon the amount of matter. And this is the old schoolboy howler of associating mass with the amount of matter. It's not. The mass is a property of matter. It depends on its electrical environment, how it's situated with respect to all other matter in the universe. What energy does it have? What motion does it have with respect to all other matter in the universe? Because measuring the mass of an object means that you're determining its energy. E equals mc squared tells you that.
Right, okay.
And yet, so the mass is an energetic variable.
So
Once you've got
mass
energy-
will change.
once
This is why
once you've got energetic variable involved, you cannot say what that body is composed of just by measuring its gravitational influence.
Right.
And this applies particularly to comets, for instance.
That's what I was going to say.
Yeah. A comet is not polarized electrically the same way as a planet. Its sphere of influence is very small. So the results you get from a spacecraft flyby will not give you the right answers. And in fact, there's also measurements of spacecraft whizzing past the Earth not behaving according to Newton's equation either. So there's all these unknowns in science which are presently thought to be solid theory, and they're not. And of course, so a newcomer like Pierre-Marie into our work, unless he takes it on board, he's not helping. He's giving a false picture of the sun.
Well, he has a close tie-up with Stephen, doesn't he? Stephen Crothers. So, have you talked to Steve about this?
Is very interested in the mathematical work that's been done by people, and of course Pierre-Marie can point to his papers in mathematics, but you have to be careful, of course, of mathematicians, because they don't worry about definitions and whatnot. They just look at the symbols on the board, and they can point out, if you've made a mistake in playing this complicated three-dimensional game of chess with symbols. That doesn't mean that having done that, you've actually helped, or you've clarified physics. Because physics has nothing really to do with mathematics.
No, physics is what it is. It's just describing what reality is, isn't it?
Physics is natural philosophy. You have to look at nature and try and observe and come up with pattern matching. This is one of the things that Velikovsky showed me was there was pattern matching across disciplines. Once you do that, you end up with a picture which actually looks a bit like nature. What we have now are pictures of the universe which have nothing to do with reality and black holes and dark energy and all of this nonsense. Simply because the mathematics can be completely misleading if you don't understand what it is you're talking about in the first place.
Yeah, makes it harder, I would have thought. Well, at this point, we're now sort of like at the halfway point between 18 and 19, and our thoughts, we've got to mention it, obviously, is our friend Dave Talbot and his unfortunate occurrence that happened during 18. And this, of course, has held up the organisation for next year, going into 19. Do you have any word on, we know it's probably going to be in Denver, but do you know sort of what month, or has Susan sort of talked to you about it at all?
We don't have a date for it yet, but may I say it won't be far away from where you are now.
That's a bit of interest.
Hang on.
Do you want to say
hang on.
Do you want to say that again?
Yeah.
Well, I'm waiting on confirmation, you see. Without confirmation, I don't want to...
No,
you can tease us. You can tease us.
But it will be in Europe, let's put it that way.
Oh, wow.
Whoa.
Well, there's a bit of a news flash for us. Thank you very much. Okay, well, that's interesting.
The
I'll get tongues wagging.
The EU will be in Europe.
Yeah, it seems like it. Okay. Well, right. Okay. Well, that's great for us because we can broadcast it live and provide we get invited, which I hopefully we will. So 2019. So we can look forward to the conference.
Yeah.
Which is really good. Hopefully, Monty and Michael will be able to give us even more of an update. Do you know any latest results coming through from Sapphire?
The Sapphire has been quiet recently because, for one thing, Monty had to move houses, and moving a house is not a simple thing. And in the middle of all that, he has been re-instrumenting the Sapphire experiment to test things which are of great interest to me, because when Monty and I were talking, designing the experiment, so to speak, I said certain things that I wanted him to do, which were beyond what Jurgens had asked for, and it involved some pretty tricky engineering. I mean, I can't believe just how lucky we've been with the people who have come in to join in the sapphire experiment. And in the process, I've met people who are sort of overseers and who are very well known in their fields outside our work. To be able to meet those people too has been wonderful. The phase 3, this is phase 3 we're looking at now, and the instrumentation is designed to test things to do with what I call plasma chemistry. And plasma chemistry involves the nuclei of atoms as well as the electrons. And I mean, Michael has given some of the way in his presentations, talking about the changing spectrum of the spectrum outputs, and we introduced nitrogen into the chamber, and all of a sudden that catalysed things that no one expected. But that's been a feature of the sapphire experiment. Our expert plasma physicist has been repeatedly surprised by what we've found, and Monty was invited last year to a meeting at, I think it was the University of Montreal. Or anyway, it was a meeting of nuclear physicists in Canada, and a couple of the physicists afterwards came up to Monty and said, "Your experiment is the most advanced in the world in this field."
I would have thought so.
Yeah, so all of these things have been very encouraging, and I've been satisfied that the sapphire experiment is doing what I hoped, which will change the world, in my opinion, because it shows us how stars really work and what the source of the energy really is. Jurgens hinted at it. It wasn't until 1994 when I went to that conference that Dave Talbot organised in Portland that I realised I was the one who had to stand up and try and champion Jurgens' work. And of course, Don Scott, when we started up again, what was it, 20 years later, 1994, it was 1997, early 2000 when Don Scott joined in, and of course we became close friends immediately.
Yeah, absolutely, I would have thought so.
And because his work from the electrical engineering point of view was also very important in being able to analyse Jurgens' model in terms of what we now know from electrical engineering theory. What Jurgens did, in my opinion, was incredible. He was a genius of the same calibre as Velikovsky, in my opinion. The detail he went into for that period in history was just amazing. And I feel privileged to have been in a position where I could actually further his work. I've now managed to contact one member of his family. I ever had one photo of him, and it was a pretty average one, you might say.
Yeah.
And so I've had one of his sons looking for family photos, and even that's been difficult. There's very few photos of him even within the family. So that's kind of a wandering answer, but
that's okay. That's right.
The Sapphire project is, I think, going to be a game changer.
I think most people would agree with you there. I mean, what we found out, even with the proof of concept model, was mind blowing. To see even in that little bell jar, see stuff go off. It's like, whoa.
Yeah, we started with the bell jar, and then we found this vacuum chamber that had been built for, I think, the space program, and was in a car park somewhere in California, and nobody wanted it, so we made an offer and then shipped it across the country.
Oh, brilliant.
Once again, all of these things have just fallen into place, which makes me feel very confident that the gods are on our side.
Either that or a bunch of aliens. Or maybe a mixture of both. You never know. Anyway, now our team, Piers has joined us, and we've got Ivan with us as well. I want...
Where's the camera?
the camera is there, in the middle of that lot. So don't worry, you're on
You look
Well,
you're looking good.
But so yeah, basically we want to
Well,
talk
we
about
wanna
what we are doing
see
this
what's
year.
behind
Whoa,
it.
shush, please. So what we're trying to do is actually start an educational side here. So we've got Piers and Ivan who's going to tell you about the higher academic level. We're going to hand over to Rob, who's going to sort of talk about our level, which is the introductory level. And then after we talked about that, we're then going to talk about health matters and our friend Dr. Chee. But for the moment, Piers, you have the floor. Please tell us what is happening with the academy.
Well, I was going to ask some questions first.
Oh, yeah, fine.
We do the
Please.
academy later on, I would have thought. Do we do that? Yeah. I can see you, Walt. Good to see you. Can you see me?
Yes.
Okay. Am I sure I'm in the right place?
Yeah, you're fine. It's
All right. Brilliant. Well, I agree with you completely that, you know, the chemistry, as you call it, of plasmas, which you're about to do more work on, is you know, potentially astoundingly important. And, you know, we're looking forward to that. But I wanted to ask some other questions about the sort of preceding things. Just as a factual thing, you mentioned earlier about errors in the trajectory of comets and rockets when they're leaving the Earth environment. What sort of errors are there in this, and what do they mean in terms of, you know, electric universe versus standard gravity?
Well, with the comets, they talk about non-gravitational accelerations. They attributed that to the jet action changing the orbit body.
Oh, okay.
But to me, that's a totally inadequate explanation. I mean, the jet action would be infinitesimal.
Yeah.
Sorry, by jet action you mean that the expansion of gases on the comet would propel it? Is that
Those jets you see coming off the surface, which are electrical machining.
Yeah.
And it's just stripping atoms and whatnot off. I mean, the thrust would be totally inadequate to change the orbit to any significant degree. What is happening is that because the internal electrical stress is changing, in other words, the internal energy of the body is changing, the actual mass of the object is changing. And as I pointed out in one of my lectures, I think the workshop was one of the first places I discussed it. When you change the mass, the orbit of the body changes because just simple ratios. You change the mass, the orbit changes in the same proportion. So this non-gravitational acceleration is actually gravitational acceleration, but acknowledging that the mass is an energetic variable according to E equals mc squared. And the same thing applies to flybys of spacecraft of the Earth, but in that case it's not so much the electrical influence, it's you have to change your view of gravity. Gravity is a balanced force. The universe doesn't operate with unbalanced forces. It doesn't make any sense. You know, why would you invent a universe that the first thing it should do is collapse on itself? And so you need a Big Bang to sort of separate the matter. This is sheer nonsense. No, gravity for a ponderable body is electric. It's an electric force, but it's a dipole force, like magnetism. This is why you can use two magnets as an example of the forces between bodies. If you face the same pole towards each other, it is a repulsive force. And the only thing that holds the orbiting systems together is the influence of all the other matter in the universe, which is also repelling and forcing things together. And then they achieve stable orbits in that situation. This is quite a different picture, and it's also a rather nice one because it means that the collisions are avoided rather than being, I mean, astronomers, all they've got is explosions and collisions to work with, and now we've just removed one of their tools
from the toolbox.
Yeah, that's very interesting.
this idea of gravitational accretion doesn't quite work the way they think.
Okay.
Each ponderable body like the Earth and the Moon has a gravitational sphere of influence, and once you're inside that, and you're a smaller object, your polarization can swing, through the whole body so that you're attracted to it. It's like iron filings to a magnet. We are sort of unpolarized, if you like, and an iron filing is unpolarized until it comes near a magnet, and then it becomes polarized and attracted. So we're held to the Earth by this kind of iron filings type effect. One of the big questions about gravity is, why is it such a weak force? And the answer there is simple. Magnetism is a much stronger force because it's you're dealing with the electrons in the outer shells of the atom, and that when they distort, their influence is quite strong. Also, they're easier to distort than a proton in the nucleus. The gravitational force is the actual distortion of the proton from the nucleus, and that requires that you have an electric field inside the atom to produce that force. And that's not so easy, at least you can't do it just by applying electric fields. This is where you can't use an electric field to influence gravity to any degree. However, Newton recognized that you can influence matter gravitationally just by spinning a bucket of water. And when you think about that, it's simple. All of the nuclei in the atoms towards the periphery are displaced from the center of the bucket, from the center of the atom. And that means that they now have a polarization which is not directed towards the Earth and is actually attracted to all the other matter in the universe. And so it tries to attach itself to the fixed stars, as they say. This was a question that was raised by Newton, and it shows that any theory of gravity has to deal with that bucket experiment and explain it simply. As far as I know, nobody has.
Well, that makes me think we're going on to Eric Laithwaite and his spinning his spinning flywheel, and the way it actually followed the path up into the air. So so is it going towards the rest of the universe?
Yes, it is. It's trying to attach itself to the fixed stars. This is why you use gyros for inertial guidance,
right?
Because they attach themselves to the fixed stars.
Okay.
I mean, it's all damn simple when you think of it that way, instead of the mathematics, which I remember when we did it in applied maths, it was pointed out this is really difficult.
Yeah.
Well, it is difficult because you have got no physical understanding of why it's doing what it's doing. So you talk about momentum without understanding mass, and angular momentum without understanding mass. Sure, it's difficult because you can't picture in your mind what the hell that means.
Yeah.
Angular momentum. Oh yeah, and it's got a vector which points in this direction. What does that mean? What is this vector?
Yeah. Piers?
Well, yeah. Of course, what you're alluding to is Mark's principle, that the inertia.
That's right. Yes, Ernst Mach had the same. I mean, a lot of top scientists at the time had that same vision that there had to be this connection with all matter through the universe.
That's right.
And one of the key principles of the electric universe. This has to be so.
Oh, I agree with that completely. Any theory which doesn't include it is inadequate. Of course, the standard physics, you see, just sort of says, oh, well, we've got absolute space here. Or that's what Newton said, and then he started pondering what was meant by absolute space. But
yes.
I agree with you completely that we do have to involve the distant matter of the universe. And a man from Bristol who came to the conference he's got other ideas on that, but at least he's on the track that there has to be involvement of the rest of the universe. Now, I wanted to go back to what you were saying about changing mass in things in comets and so forth, because you see, put simply, if you have your mv squared over r equals big G m times the mass of the star or something over r squared, then you see the two m's cancel. So a changing mass in the simple sense won't change actually the orbit at all. So there has to be something more subtle, which I think is what you were alluding to. Something more subtle has to change the orbit than just saying the mass shifts, because you see what I mean? Understanding mechanics, it won't matter.
Well, going by...
It's just like cutting a body into two halves, okay? Both halves will all be
I think you have to have a look at my presentation in the workshop I did in 2014. I think I went through it there. It's also on my website too, under Electric Gravity, I think was the title. But this was one of the things, of course, that way back in when was it I visited? 1979, I visited Velikovsky. And I said to him that the single greatest problem he faced was that it didn't obey Newton's laws. And I realised that from the work of Dave Talbot and Dwight Cardona, that for us to have survived all of this episode that they'd uncovered of the excursions in the solar system, the relationship between Saturn, Mars, Earth and Venus, the solar system had to be able to re-establish order very quickly, otherwise we wouldn't have survived. And the ancients recorded, periods when the Earth must have been on an elliptical orbit, because they complained the twilight of the gods and the Fimbul winter, the terrible cold. And then on the other hand, they were then complaining about the sun was too low in the sky. The sky had to be lifted. The South Pacific Islands.
So that would make the tilt of the Earth and change, would it?
Yeah, so those wild excursions that they found in the geological record of temperature would have been that period. And I realised that it had to re-establish order very quickly. And so it had to involve electrical exchanges between bodies and electrical exchanges of objects on a cometary orbit. Because that's all that's happening, is that an object on an elliptical orbit is exchanging electrical energy for orbital energy. And this is the problem of ways of capture. How do you capture an object? How do you remove the energy from its orbit so that it is captured? And that was the answer I came up with. The electrical exchanges that Velikovsky had uncovered had to be a part of the stabilising mechanism. And when I
change the energy in the orbit, and therefore the orbit is.
When I went through it, I figured that this was how I figured that was how it worked, and I'm happy to have revised that if anyone comes up with better ideas. But I think those are the critical observational facts that had to be dealt with.
Excellent. So I should look at your 2014.
The evidence for it actually was fairly strong, because Dwight Cardona's work and Dave Talbot's of this so-called polar discharge column between the planets indicated that we were sitting in the tail of the comet formed by a former star, protoplanet. And that matched with my view that the minor star entering the electrical environment of a bright star would switch from being a star to being a comet. And so all of this fits together. Anyway, have a look at what I did, and if you have any comments, I'll be happy to receive them.
Yeah, Piers, just I wondered, this notion of these interacting plasma bodies, is there an analogue you're aware of? As a teacher, I'd be very interested in trying to communicate that idea in a way that's perhaps more intuitive to someone without an a background in electrical engineering. Are there any analogues for that you can think of? Something a bit more easy for. Sorry,
Layman.
More lay.
Lay person.
Yes, lay person.
Okay, let's not go into that. Yeah, but are there any analogues you suggest for trying to describe this to people, because it's a big conceptual leap.
The mathematics is just high school stuff. It's easy. If you say, look at my article on my website on electric gravity, I describe it there, and I give you the equations. I mean, it's just very simple.
Okay.
That's the Hollow Science website. Is that your one?
Yes, that's right. Yeah, but I describe it, I think, in that 2014 workshop that we gave in wherever it was, Seattle or somewhere.
Yeah, I don't know where you done that. I saw it though. Yeah, it's good.
Wherever it was, yeah.
Okay,
This is one of the problems, of course, that I face, and I have to say that it's been my desire and plan for some years now to, since I figured out gravity, I thought, I have to write the book that pulls all this material together, because I see people hairing off with ideas which have nothing to do with the electric universe and trying to attribute it to the electric universe. So I need to set out the history of ideas, my ideas, how that fits with other things, and also try and establish a narrative which people can refer to. And I have to say that, once again, when I have a dream of something, the person I need just pops up. And I have a chap here who was a leading lawyer in Australia, who's made it his life's ambition to get this book done, and done quickly. And he's taking it from a legal perspective. How do you set up these arguments so that they're unassailable in court? This is something that scientists never do.
Yeah.
Most ideas in science and most books and theories that are published, if they had to stand up and be cross-examined, they'd be, like most expert witnesses, tossed out.
It would be, yeah.
So, just to the point, is that why you trademarked Electric Universe, to keep it pure to what you and Dave set up? Because
Yes,
a lot of people have asked about
back
that.
in the turn of the millennium, somewhere around about 98, 2000, and I've paid my dues to keep it going, simply because I felt that it was important.
Okay. There's just a few people asked that, and so over the week we've had a few people asking us questions to ask you.
Well, yeah, it was raised with me 4 or 5 years ago, when we had people who'd been to our conferences, and we thought that we were open to having one of these people trademark our work and then try and sell it back to us.
Yeah.
Was that another lawyer?
Yeah, and I said, well, I already thought of that, and so it's trademarked in Australia.
Well
I did that in the early days.
Okay. Piers, anything else?
Yeah, yes. Well, I wanted to ask you a bit more about Berkeley currents. I've seen Don's superb paper, you know, with the mathematics in it, and referring to stuff that went before on Bessel functions and so forth, which is really excellent. However,
Yes.
a couple of questions about it. Supposedly, if you have got two Berkeley currents near each other, they will wrap around each other. Now, the reasons for that maybe ought to discuss somewhere else, but it might take a long time. But you see, how can this work in practice? Because you see, supposedly we're going to have roughly in the plane of the sun's equator, there'll be lots of Berkeley currents coming out, you see, mixed up with the ejected material. Now, some of these will be connected to planets, right? So some will connect to Earth, some to Jupiter, and so forth. However, you see, you then see you've got these strings in space. Now, when they cross over due to orbit or whatever, they can't wrap round each other. You know, two strings crossing can't wrap round each other. They're going to be crossing. So, you know, something's going to happen there. So a question has to be, you know, what does happen if you've got two Berkeley currents kind of interacting, trying to cross each other? Because they can't wrap round because the ends are fixed somewhere else. You see what I mean?
Yes.
Could be a very important question.
Of course, and in fact, this is still some aspects of it are an open question.
Yeah.
What you've got to look at the scale of things. I mean, there are plasma filaments of all different scales,
Of course.
and there's ones for the galaxies, there's ones for stars, and then there's ones for within the, if you like, the electrical cell wall that is the heliosphere of the sun. The sun is protected from its galactic environment by the heliosphere, the cell wall, the virtual cathode. And within that, there will be there's current sheets as well as current filaments. And the sun's current sheet, equatorial one, actually connects the sun with its environment. and there must be a Birkeland current which is quite huge, which surrounds the solar system.
Right.
Now, the interactions between all of those is something that Don Scott and I have puzzled over, because with the structure that he's shown, and the fact that your magnetic field changes direction in the different cylindrical.
As you go along it, yeah.
That's right. There is actually voltage differences between the central discharge column and the cylinders around it, and the current sheet from the sun's equator goes out and closes the circuit between the central column and the next cylinder out. Now, it seems that the current is possibly going in one direction in the polar, along the poles, and the Birkeland current on the outside of that, the current is flowing in the opposite direction. It's like the water bridge, where you have the water going one direction in the periphery, and down the axis it's going the other direction, so that the water level in the two beakers, if you like, in that water bridge doesn't change, even though the water's travelling between the two. Right. With that high voltage bridge. Oh. I think similar things happen with stars. Now, as I said, this is still a work in progress, because it is complicated, and we need to have spacecraft fly directly over the poles of the sun, rather than at 70 degrees or whatever it was that Ulysses got to actually tap into and find out what is the plasma doing there. All we know is that they discovered wavy things, which is exactly what we'd expect, of course.
Yeah. Or magnetic ropes or whatever they say,
Yeah, we need more details. And mapping the magnetic fields is one of the ways of doing that, because the currents follow the magnetic field. In the case of the planets and their Birkeland currents, they are confined within the cometary magnetotails. Okay. So that when, for instance, Mars and the Earth align, Mars is in opposition, the Earth's tail sweeps across Mars, and it causes those violent dust storms and so on.
Okay, so Birkeland currents don't go into... Okay. So Birkeland currents don't enter in the polar regions of the Earth then? They're all connected to the...
Oh, they will if there's a magnetic field. They'll follow the magnetic field lines down to the surface, but Mars has got a very complex and messy magnetic field, so...
it's quite patchy, isn't it? It's quite patchy.
Yeah.
Which I would suggest we look for water under those patches, because I would imagine it's the salt water that's actually would be carrying the charge and producing those fields, or not.
What I'd suggest is that this work for somebody else.
or if they gave us some money, we could design the experiments and
try and match the patchy magnetic field with the spots where these storms seem to arise from, because certain regions on Mars seem to be the source of these storms when they begin. Right. Now, if they could track that down to the magnetic field pattern on Mars, that would be another tick for the electric universe.
Sounds pretty good to me.
Absolutely.
Right.
Just looking at this
plasma ball.
Yeah. So these are not actually Birkeland currents.
Yes, they are.
Are they Birkeland currents or not?
Because you can see where they split as well. Because that's two currents.
Would you describe these as Birkeland currents, Wal?
Yes, the electric currents in plasma will always tend to form filaments.
Oh, okay. So they are. Well, the interesting thing is that they're not wrapping around each other.
Yeah, there's two. You can see them separate as they separate as they hit the surface, which is exactly what happens. Is as soon as you come to matter, it will separate again. Because you see this.
Don't touch it. Do it again.
There you just get the one. You can see where they're hitting the actual globe. They're splitting.
No, I see that.
Yeah, that's because there's two currents
they're not
together.
actually wrapping around each other in the space.
Individual ones will go in the same direction. They would, just wrap around it like bindweed.
Okay. All right. They might be trying to. I agree. But the point I was making about the ones connecting the sun and the planets is that they're restrained from wrapping around, which is why there's a lot of important work to be done.
Yeah, there's this one. You're wondering whether they actually release from the surface and then rejoin depending on the conditions. You know, so they don't have to be constant, I suppose.
And also, what the sign of the electric current coming out of the equator of the sun changes in the magnetic cycle. So, would that mean then that what goes into the poles of the sun also changes in the magnetic cycle in directions?
No, it's not. No, it's a DC. It's a what would you call it? A varying DC current.
Okay.
And it's the variation in the DC which generates the changing magnetic field on the sun. In other words, it's a bit like a choke in an electric circuit. When you've got the current increasing, the magnetic field will be changing, will be in a certain direction, and then when it stops and starts reversing, the magnetic field will switch. And this is what Don Scott's diagram, the magnetic field effect of the sun. It's very easily explained by the transfer of charge or electric currents from the poles to the equator. But it's always a DC, varying DC.
Okay, so DC. Yeah, it could still be a DC, even though what happens at the equator could change sign, but there's a total current.
That's right. Yes, it's the actual change.
Okay. Well, that needs a lot of clarification. Now, can you get Birkeland currents, say, going to the belt of small objects around the sun? Will they receive Birkeland currents as well?
Yeah.
But even though they haven't got magnetic fields, can they still receive Birkeland currents?
Oh, yes. Yeah, they're still subject to the interaction with the environment electrically. Venus is an example. And with Venus, the ionosphere is in
well, I was talking about the asteroid belt, you see, which have got, they're not hot objects and probably not having magnetic fields. Can you still get Birkeland currents fixing onto the asteroid belt or members of it?
Yes, it depends on the whether your object is
magnetized, maybe.
No. Whether the voltage difference is such that it has to actually discharge. Because normally what happens is they just set up a plasma sheath around them, a Langmuir plasma sheath.
Yeah.
And that stabilizes the voltage difference between that object and its surroundings. In the case of the Earth, for instance, it has a number of plasma sheaths surrounding it. The ionosphere, the magnetosphere, all of those are plasma sheaths. And that protects us from the voltages that are outside our electrical sphere of influence. And that's important also from the view of determining what causes the magnetic field of the body. A rotating charged body will generate a dipole field. And geologists dismissed the idea that it was due to the Earth being charged simply on the basis that they calculated what voltage would be required. But what they didn't take into account was the plasma effects and the plasma shielding that occurs. All of the objects in the solar system, unless the plasma sheaths touch, don't see each other electrically. They're insulated from each other and from the sun. It's only when the plasma sheaths connect that you get these electrical exchanges between them. Okay.
So items like Ceres in the asteroid belt, which is, I think that's the biggest one, isn't it? They probably do have some interactions, but they're going to be a lot.
Yes, they would. The solar wind, as it's called, that electric current passes by them, and therefore it will have an effect. But because they're not changing their distance from the sun and their voltage is fairly steady at that distance, you won't see plasma sheaths formed, comas, and you won't see an comet tail.
Right.
It's interesting that some of these objects, some of these asteroids actually do have this ability to switch from being an asteroid to looking like a comet.
Oh, which ones are those?
What was it called? Chiron, I think, was one. The reason for that is, of course, that the solar wind is not a steady source of current. It changes, and so if you get a coronal mass ejection, that's a massive injection of electric current in a certain direction. If that asteroid is in the path of that CME, you can expect to see cometary effects on that asteroid.
Yeah.
Okay. So, can we now talk about what our plans we're doing as far as the Academy goes, and then we'll talk...
We can, but 2 seconds about the sun.
Okay.
Can we ask more on the sun? You were talking earlier about whether the nuclear furnace in the centre of the sun was compatible with the electric model in any sense. Is it compatible in any sense? I mean, could you have a mixed model with nuclear activity as well? You couldn't. Okay.
Yeah, no, it's not compatible at all. And the very fact that sunspots are dark is the best evidence that there's nothing going on beneath the photosphere of any significance. The other aspect of it is that with gravity being a repulsive force between celestial bodies, it means that the interiors of these bodies will suffer a repulsive force which will tend to support a shell rather than a solid or liquid throughout body. And so it's quite possible that planets and whatnot have empty centres. Now they're shelled. And that has all sorts of implications. Now there is evidence for the Earth that suggests that the simplest model of the deep seismic data is that the Earth is hollow. It explains the shadowing effect that you get from deep earthquakes on the other side of the Earth very simply, without any ad hoc inner cores, outer cores, and all the other stuff that they've had to try and had to add to the standard model of the planet to explain. And so I think that this is quite likely that large bodies in the solar system, and even smaller ones, can be hollow. Now, we've done experiments in producing the Martian blueberries. And interestingly, in that experiment that C.J. Ransom did, he produced those double-lobed objects.
Peanuts.
And also some of the spheres, I believe, were hollow. So the electrical formation of bodies, I think, can be invoked to explain all of these things, including the strange shape of this latest deep object in space, Ultima Thule. And also the comets and asteroids that have been found that have this dumbbell kind of shape.
Okay. Well, that's amazing.
All of these things are now open to investigation from a point of view which already has some experimental evidence in trade writing.
Yeah. No, very interesting. Okay, well, that's there's loads more questions, but I think that'll be.
Well, we can go back to after that. We want to get this education thing. So that's big for this year, and today's thing is about reviewing last year and looking at the next year, or this year. And so can you tell us a bit about the plans for the Academy?
Yeah.
Please do.
Yeah, okay. Right. Yeah, this idea of the Academy was to draw together different people and influences around the world, Walt, where we would set up what we called a high profile. Yeah, we want to increase profile, that's for sure. A independent academy for accountable science, where we would do numbers of things, but one is we would review. We'd have people with qualifications in reviewing, peer review stuff. In a completely open manner. We changed the peer review system. Now, this might sound pretty grand, but of course, once you start doing it, and if anyone pays attention, then eventually what we said would get noticed. So that's one thing this independent academy would do. Another thing is it would actually run courses and lectures on, alternative ideas. Obviously, certainly a lot of mainstream people aren't going to like it at all, but if we do it in the right way, we could maybe make an impact. So we're anxious to get different groups together. Now, when we went to the conference in Porto, the Climate Realists Conference, where people were there disagreeing with the standard CO2 nonsense model of climate, we got a lot of support there. So I think, you know, there's qualified as well as, you know, interested people who would support us on that. In Britain we have interest, and of course we've got Electric Universe people here. We did have one meeting in 20th of December, which, although not exactly billed as the start of Accountable Science Academy, it was essentially that, where we had a really very interesting set of presentations which are available on YouTube. Ivan here is, and Bert, is going to be, and me are going to draw together a kind of a charter for this thing, but then we'll circulate it around and get people to join in. But we'd be very interested in getting expert people like yourself involved in various ways, well, obviously making presentations, but also at the level of doing peer review of stuff, because some of the stuff that goes out is complete nonsense, and it ought to be properly peer reviewed in a public manner by people who understand, who understand physics instead of rather just, you know, making PR narrative stuff. So, you know, we're interested in your comments and involvement on all this.
Okay. Very early on, I realised that this has to be a groundswell movement, right. And I decided it was a waste of my time playing the academic games, because they'll shift the goalposts and do everything they can to shut you down.
Yeah.
And I still think this is the way I want to go. You know, I want to involve people in society, because it has to be a cultural change. It's not just a scientific one. So I'm very keen to involve artists and writers of all descriptions. When it comes to peer review, I've said to people that peer review is good, provided you have any peers. And at present, the way I'm doing science is not taught in the university on Earth. So it's pointless asking for somebody to review my stuff when experts will try and pick holes in it from all different angles. This is one of the reasons I want to get this book written. And with this guide, because the plan is to set it out in such a way that it would stand up to cross-examination by the educated people, you know. And this is the sort of thing that Professor Tommy Gold proposed. He said there should be a science court, and that court involves educated people who are not in discipline that's under investigation at the time, so that when people propose these billion-dollar experiments, they can be taken to the court and cross-examined by educated people. And if they can't explain what the heck it is they're doing in ways that they can understand, then you just say, no, next.
Well, that's absolutely right, because a lot of those projects are just theft by Wall Street corporations to satisfy the political narrative of man-made climate, so-called change. But I think that's a very interesting idea, which does fit into the sort of things you just said.
I think what you're trying to set up is good. In fact, we thought of it some years ago and went through a lot of the planning aspects, but it's sitting in a drawer in Dave Talbot's office, I think.
Okay, well,
so I went to all the meetings, and it was to do with an online university, you know, one where people could join in without having to physically be anywhere near the centre of action. So I think that the online aspect is important.
Okay.
My other point is too, I think that what will happen, and is already happening with me, is that people are writing to me who have PhDs and they want to know where they can learn more. And I've got scientists in Germany writing to me and sending me their papers, and they pointed out that they'd actually used some of the Electric Universe ideas, although they're not specifically mentioned as such, in these papers. We've set up a dialogue where I'm pointing to possibilities in their work which may actually assist me as well as themselves. So this is the kind of interaction I think that is useful and is sort of runs in parallel with academia, but we don't have to get involved in their games, if you know what I mean.
No, we have to create a game which they might have to focus on and accept. Because you're right, if you go to Imperial College, for example, and start talking to somebody, then you're going to get drawn into, well, I do go there and talk to people, but you can get imprisoned in a very narrow framework.
Oh, yeah. Well, one of the first questions always is, show me the mathematics. And I'll say, what mathematics?
Right.
Show me your mathematics and I'll show you the whole thing.
On the on the lower level, we're obviously trying to do an entry level. Obviously, Piers is working on the higher academic level. So I'm going to hand over to Rob now and let him explain a bit about what we're going to do on the entry level.
Thank you. So the plan is really to use this monthly get-together, hopefully, as a way of focusing discussion. I'm getting the camera around certain topics. I mean, one of the most intuitively satisfying things I'd say about the electric universe model is the, let's say, the fractal nature of things and the way things operate on different scales. From my background in education, it seems to me natural to try and organise, let's say, an entry-level curriculum to electric universe theory on the basis of scale.
Yeah.
So, what we're
having said that, you might be interested to know that this fellow who's helping me write the book said, I've suddenly realised we need two books. One which has all the details in it, and the other one which is a narrative style, which could be used for schools and things.
I'm offering myself right now. You can make your own judgment. You don't have to answer right now, but I'd be delighted to help. But the idea is we have our meetings the first Sunday of every month. So next 3rd of February, what we're going to be focusing on is really the atomic and molecular level. Again, on an entry-level basis, just trying to think of the most important details electric universe theory can add to that level of scale. Then on March the 3rd, we'll be looking at cells and organs. Hopefully on the 7th of April, we'll be looking at the whole organism level, like the human-animal level. Maybe, hopefully, with either Eileen McCusick or Jerry Tennant, depending on what we can organise. And then just to go on in May, we're looking at the weather, environment and things on a planetary scale, and we hope Piers will contribute. And then on June the 2nd, talk to Michael Carriage about the galactic level of things. And again, to try and organise a curriculum on the basis of scale, using the conversations to talk about and elucidate what are the highlight, the headline factors that electric universe can bring to those levels of scale, and using that as our way of organising things. Following on from that, we'd be able to then, having had those discussions, we'd have the level of scale, say the atomic, some subheadings, for example, obviously Edwin's structured atom model. There's a lot of people who advocate a vorticimal, I can't say the word. Vortices, thank you. Model.
I'd keep away from vortices.
That's straight away, that's very useful information. So there are these different theories that and different approaches that electric universe can bring to these different elements on a scalar basis. And what we'd be looking to do, or what we are going to do, is over the next 6 months try and work out what the headlines, if you like, of the curriculum will be. Following on from that, we'll try and delve into it a bit deeper and go into the sub-subheadings, if you see what I mean, on a fractal basis. But the plan is over the next 5 meetings that we try and use these as ways of getting experts to come in and talk to us about what the headline contributions EU theory can make to these levels of scale.
I'd be interested to see what you come up with, because that is more or less the kind of idea I got for the second book, the narrative one.
Right.
Because narrative one will have to lay down the bedrock principles of the electric universe first,
Yeah.
and then build on that. And the bedrock is very simple, and I can refer back to some of the great names in the past who actually had the same ideas.
Well, I'd be interested to note that, for example, was it the IEEE?
IEEE, yeah.
Thank you. Talk about things in that scale. Also, I mean, going from the Ian McGilchrist work, there's a natural analytical left brain and, if you like, synthetical right brain approach you can take to this scalar approach. This is my background, slightly psychology and education. There is a neurological basis for talking about things in this way. So it's a very potentially powerful approach and one that's very natural.
Yeah, I think one of the aspects of teaching kids in school this stuff and getting them excited, because I think kids need to be excited about science again. Like when I was a kid, they'd lost that, I think.
I have a Tesla call here that some very excited teenagers broke for me. I did the thing with the Tesla call and the fluorescent light, and they'd obviously never seen anything like it. And within about half an hour, they tested it to destruction anyway. But these things do really engage. I mean, again,
that's it. Toys. That's what got me into physics is the fact that we had the toys to play with. Because you can literally, in the physics department, we were very lucky in what we had, back in the late 60s, early 70s. And that certainly got my interest. And it's that physical hand-on practical thing that gets people engaged. Very much so.
Yeah.
I've got bits of quartz here that I show people, the piezoelectric effect and so on. And just things like that, I think are so intuitive and so material that there's no reason to even bring up maths or theory, because you can see it right there.
No, physics is about the physical world, so you need to be able to show physical experiments, and magnets and gyros and all these things are wonderful for that.
Exactly. Yeah, that's very much the sort of, that approach is very much the one we hope to take. So we can, there's theory which is, not for everyone. Let's say the higher mathematics, the higher physics is not for everyone. Listening to you and Piers talk, I realise my limitations. But there are things I can do as we can do as communicators to make these concepts more concrete and more obvious to people. And that would be really what our aim would be, to hopefully test out the course as a 1-day or maybe 2-day course over the summer.
At the academy.
I was going to say God willing, but at the academy. But that's essentially our programme for the next 6 months, is to try and delve a little deeper into this idea of organising things by scale, and then from that build up, having pulled community resources together, put together what my girlfriend tells me is called a MOOC, which is a massive open online course, which is then I'm learning, but it's this idea that, as you say, you have then the videos, all the incredible stuff you guys have produced, and other more maybe tailored stuff around this, if you like, this toast rack or this skeleton of the idea of scale. And I'd be, if you mentioned Dave Talbot has something in his drawer that may be relevant. Obviously,
the thing is, we're going to get something written down, then we're going to send it through to you for your approval, comments, and whatever. So if you're up for that's fine.
That'd be amazing.
We'll be doing that over the next few months. Okay.
Thank you.
I was going to say something to what Rob said. I think that's very, inspiring basic idea. But I would say don't run away from maths, because mathematics actually isn't difficult. The problem is often the way it's taught.
Okay. I agree with Piers that the maths is important, but when it's got physical definitions behind all the symbols being used, it makes it much clearer to the student.
That's right.
I think maths fails in that it goes off into mysticism, very quickly.
Well, that's basically what Feynman said. He said the problem with modern physics, he said, even though he's very important in modern physics, was a lot of it has got taken over by the mathematicians.
That's it, yeah.
Yes. For example, Boyle's law you can show relatively simply with some, gas in a balloon and so on. And once you have those physical analogues, actually imparting the maths of it becomes much more intuitive. And that's right. Again, I'm not here to disparage maths, but it wouldn't be our starting point. Our starting point would be tactile, kinesthetic kind of activities, actual physical experiments, that then lead you to the maths. Yeah.
I think the other aspect that's important too is the history of ideas. Kids need to know how these ideas came about, because there are those who are interested in the that story, and also it's a damned interesting story. You know, you can do whole documentaries about the development of one particular idea. And when you set the context in which those ideas came about and how it was decided that was right and this was wrong, it gives the kids a much clearer picture of how science is done, or should be done.
I mean, again, like the scalar notion would be like maybe your y-axis, if you like, and then the chronological could be your x-axis, and you could perhaps organise things along that kind of basis. But for me, what is deeply intuitive, and I've found other people who who now call me a pseudoscientist, thanks to you. They get the scalar things straight away. Like the fact that you get these different shapes or morphologies on different scales is immediately very powerful and very intuitive. So it's a great way as a teacher to try and get the point across. And again, for me, the idea of trying to teach it seems to me, because of the, if you like, the echoes that you get between the different scales, how these different, how the human body, for example, needs to ground, and a star needs to ground. These things echo across the scales. And as you can tell, I
hope it's possible also to give a much clearer idea of the connection between matter and the various levels that you go up from there, including things that are not even recognised by biologists when it comes to living systems. And when you tie this together, for instance, this is just an example, the electric universe, having figured out that the planets and all matter in the universe has to be tied up in real time. You can't have time delays, because then you get energy losses and the whole thing just falls apart. Same thing applies to biological systems. And so you realise that the same signalling that planets use to know how to orbit the sun without losing energy is the same signalling system that's used in living systems to keep control of all these trillions of things that are happening at any instant.
Well, again,
this doesn't appear in any biology class, because all they talk about is nerve signals, slow nerve signals, and the speed of light delay and all that bullshit. It just doesn't work.
Well, again, Arlie McCusick is very, I'd say, poetic about this. You've provided people like us with a connected cosmology. And no star is an island. It's a beautiful phrase, sir.
That's right.
So you've provided us with something to elaborate on.
I think that take that one step further, that also applies culturally. Because you then suddenly realise we're connected to the Earth, we're connected to each other, we're all part of something grander than we conceive of at present, because what science has done in the past is take things apart and look at the bits.
Atomize.
They've never figured out how to put it all back together again, so it doesn't work.
The Humpty Dumpty of physics, sorry.
Culturally, culturally, I would say the key problem we've got is what we call consensus now, because the mainstream narrative is that consensus rules. Consensus has been reached on climate, on everything, and anyone that comes up with a new idea is deemed to be, a pseudoscientist or a heretic or a denier, and it's really completely anti-scientific what is going on now. So your idea about doing the history of ideas, I mean, that scares the shit out of a lot of people. In the top
I said no swearing, Piers, for fuck's sake.
Sorry. Well, Americans have perfected the art of enforcing consensus.
Yes, that's what we have, enforced consensus now, led by the BBC and all the mainstream media in the world.
Alright, so people, I'm going to cut in here because we are running low on time, and I do want to bring Dr. Wong in.
Of course.
Because we are talking about what we are doing on the medical side and what we're going to be doing this year in 2019, and which we hope will change medical practice worldwide after that. So, please,
Hi, Wal. So my name is John. I work in intensive care at London Bridge. My background is from anesthetics, and I've had a chance to look at long-term patients with hypoxic brain injury. And I wondered, why do some patients get better and some don't? Well, our cells operate at pH 7.35 to 7.45. pH just means potential voltage, or hydrogen. So basically, all cells are running across a voltage. So operationally, cells need to run at minus 20 to minus 25 millivolts. And apparently in healing cells, it's minus 50 millivolts. So when a patient stays on the bed for a long time, they get a net positive charge. And this is what you see when you're tired or you're sick or you get cancer states. You get a very acidotic or high acid system, or that's a very positive charge. So if you can do if you can simply hug somebody, touch them, you can transfer the high voltage of electrons from yourself to the patients to naturalize it, and they get better. Therefore, when you got a sick child, you give them a hug, the child gets better, you get sick. Similar principle, what if we can ground patients who sit on the bed for a long time? So maybe their wounds will heal better. So maybe if there's a gap in your wound, if they can get that minus 50 millivolts, maybe that wound will heal perfectly. And if you can't get minus 50 millivolts, you get chronic disease, you get constant pain. So applying a simple ground wire to the body, to the grounds, may help discharge things. And that's why walking barefoot is really great, because you move the high voltage from the ground to your body. So if your body is very low with that, you just get the extra electrons, so you can build new cells and have energy. When you exercise, your muscles are piezoelectric, and they generate and recharge your battery as well. So that's the plan in a nutshell.
Okay. No, well, actually, I agree with you. We've actually had the earthing guy at one of our meetings a few years back, but I'd already known about his work, and I actually have an earthing sheet in my bed. So I'm hoping to be able to live long enough to see some changes in society.
Well, you don't look bad on it so far.
But basically, we don't have to have anything too complex. Just stay away from bottled water, which is acidic, chlorinated water. Hug a tree, hug a person, stroke a cat, go for walks, and you'll live long.
This comes down to this business that I was saying before, that we are a part of the earth. We're connected to the earth in ways that are not actually understood at present. And that comes down also not just to the plain electrical potentials, but also to the signalling system. And this is why medicine has to open itself to the natural therapist, because the natural therapists have known about this, what they call subtle energy, for some time. And so we have to pay attention to them. The electric universe model gives you a way of looking at it scientifically for the first time. And I think if we do that, then medicine will go ahead in leaps and bounds, because it won't be treating us with chemical interference in systems they don't understand. It'll be a case of trying to actually modify the communication between the living organism and its surroundings, because that's essential. Part of it is the electrical, just the plain electrical side of it. The other part is the understanding of the signaling that we use for consciousness, memory, and the control of a living system.
As a small aside, I mean, on planet Earth, the Schumann resonance is roughly about 7.83 hertz. Interesting enough, for the healing cell, minus 50 millivolts is equivalent to pH 7.88. So on Earth, that's what it takes.
So this thing here, it's a Schumann resonance Tesla device, which I'm testing.
Right.
Very good.
It uses the Tesla mechanism, which I believe is correct, and that is the direct electrical signaling, not the transverse wave, light wave type of signaling, or electromagnetic signaling.
So electrodynamic.
What it's doing is broadcasting the Schumann resonance to me up close and personal to override all the electrical interference that I have to put up with computers and Wi-Fi and God knows what else.
So you have to send us a small unit to maybe test out in UK as well.
So how can you actually test it? I mean, can you actually test such a thing?
Well, I'm testing it to see whether it makes me feel good.
That's probably right.
Or does it make you feel any worse?
It's purely subjective, but I feel that it's important and worth a try. I did it on the basis that I'd watched the kinesiologist use this to test for a kinesiologist who I have great respect for. And he had one of my granddaughters who is apparently very sensitive to outside electrical interference. My house is designed so I can switch the Wi-Fi off overnight when I go to bed, so I'm not bombarded with Wi-Fi.
No, I turn mine off every night.
We use a wired Ethernet connection between all the computers and other gadgets here, and I only use Wi-Fi if I have to. Now, this granddaughter, when tested by the kinesiologist, showed this sensitivity to Wi-Fi. And so he took this device, the Blue Shield gadget, and put it on her chest and tested again. And she was, how the kinesiologists test, muscle testing and so on. She went from weak to strong. So I thought, okay, well, that's a good test from his point of view. I'd just like to try one out and see if it makes a difference. And I feel it does.
Brilliant.
Well, I go to gym regularly, and my performance at the gym took a sudden increase afterwards.
Oh, brilliant.
There was another test.
Have to do a double blind somehow.
Okay, well, the back fell off and I had to return it. For those weeks that I returned it, my performance at the gym dropped off again. Well, I think we've just about hit our time limit, really. And we'd like to thank Wal, of course, for joining us. I mean, what an absolute delight it's been. And obviously this is going to be available as a record, so you can actually watch yourself at a later date, which would be good. And we'll talk again. And I'd like to thank everyone in Facebook land for joining us. And hopefully we'll see you again next month on the first Sunday of the month. So, thank you. So, thank you, Wal.
Every success.
Hey, lovely.